In this problem, we're given a positive number x, and we're trying to find the smallest positive integer number such that the sum of its digits is equal to x. But the key thing is that all the digits are distinct. So firstly, all the possible digits that we could have would be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? And the first thing to notice is that we'll never use 0 at all, because we are trying to find the smallest positive integer number such that the sum is equivalent to x, right? So let's say we're looking at 50. One answer we could have would be 96, right? But 960 would work too, but that makes the number a lot larger, and our goal is to find the smallest, so we'll never use 0, right? So it's only these 9 numbers. So then the next thing to notice is what we really want to do is we want to decrease the number of digits, and then after we do that, we want to output our answer from the smallest number to the largest number. So what does that even mean, right? Let's start with some x equals 30. That's this one. 20. Yeah, 20, right? So what we could do is to decrease the digits is to use the largest number in this set and see if it fits into x, and if it does, then we add that to our answer, and then if it doesn't, we just move on, right? So let's say our answer here, so can 9 fit in 20? Yes, so we'll add 9 to our answer, and that means the number we're looking for now is 11, and then we take away 9 from our set. So the new largest element now is 8. Can 8 fit in 11? Yes. So we add 8 to our answer, and then we take 8 out of our set. Now the new sum that we're looking for is 3. Can 7 fit? No. Can 6, can 5, can 4? No. Can 3 fit? Yes. So then we put 3 in our answer as well. And then we're left with 0, and then we're done, right? So now we know that 9, 8, 3, these are the numbers that make up 20 using the least amount of digits, right? But now we also want to make sure that the number is as small as possible, and the way we do this is we put the smallest number at the front, right? So now this becomes 3, 8, 9, and that's our answer. So we just do this method, and yeah. Oh, also the key thing to note, right, is the sum of all the numbers from 1 to 9 is equal to 45, right? So since t is all the way until 50, all the numbers 46, 47, 48, 49, and 50 will always be you will never be able to make that sum using unique digits, and that's because the maximum sum you can make using all the 10 unique digits is 45, because okay, if we include the 0, then it's 10, right? So any number bigger than 45 you just won't be able to make. So yeah, we try to put this in code right now. So are we given t? Yeah, okay. So int t, we read in t, we solve for it, and then we're just given x. So we're given some integer x all the way until 50, and then let's say our answer is initially empty, right? So if x is bigger than 45, there is no answer. So x is less than or equal to 45. Let's try and find the answer in this case. So we know straight away if x is less than 10, we can just use one of the numbers in this set, and then we're done, right? So if x is less than 10, we just increment that digit to our answer. So that would be x plus 0. So this just converts the integer into the character of the same thing. So if x here would be 9, this converts it to the string 9. So that's all this does, and then it just puts that into our answer, right? So let's say it's not the case and our x is bigger than 9. So instead of holding a set, let's just have some number called current number, which is equal to 9, and then every time we go down this and find the next biggest element, we just decrease current number by 1. So while x is not equal to 0, so if x minus kernum is less than 0, then minus kernum. So what this does is, let's say x is 4, but we're currently at 8, right? So we can't use 8, right? So x minus kernum would be less than 0. So then we would just keep on going down, 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 down until we reach x equals 4, and at that point, x minus kernum would be equal to 0, and then we will continue on. So now that we found the next best integer to use, we would add this integer to our answer, kernum plus 0, and then we would decrement x by kernum. And then once we finish using, let's say, this 4, we'd have to keep on going. Okay. Minus kernum. Yeah, that makes sense. And then, so in the end, so let's say if the number is bigger than 45, so then you can just say if ans is equivalent to empty, and this is only the case when the number is bigger than 45 because we never otherwise change answer, then we output -1, otherwise we would output our answer. We do a new line. But this is still wrong because our answer, because we're going down the list, right? So currently our answer would look like here, 983, but we want it to be in increasing order. So since our current number goes from highest to lowest, our answer currently would be in decreasing order. So all we have to do is just reverse the string completely. So if we just reverse the answer, then that should be correct. Yep. Copy that. Submit. Send. And hopefully this should pass. And voila!